Dear students, Namaste, good morning to you all, and also welcome to another session of our mathematics class. In the previous session, we have completed chapter number 10, that is vector algebra. Hope you have revised well. In today's session, we shall discuss a new chapter, that is chapter number 11 from NCERT textbook, three-dimensional geometry. Let's move on to the topic. Let's begin with the basics. In three-dimensional coordinate system, we deal with three mutually perpendicular axes called x, y and z axis. That is x dash, y dash and z dash axis. And the intersection of all these three axes we call it as origin, and the coordinates of origin are 0, 0, 0. The plane contains x, y axis is called xy plane, and the plane contains y, z axis is called yz plane, and finally the plane contains z, x axis is called xz plane. Next we shall discuss direction cosines and direction ratios of a line. Direction cosines of a line. Consider the coordinate axes x, y and z, and let's mark the origin O, and there is a directed line segment L. This directed line segment L makes an angle alpha with the positive direction of x-axis, and beta with the positive direction of y-axis, and gamma with the positive direction of z-axis. Then the direction cosines of a line are the cosines of the angles between the line and the coordinate axis, usually represented by the letters L, M and N respectively. In case of vectors also we have learned the direction cosines. There also we represented the direction cosines by using the letter L, M and N respectively. Here L is equal to cos alpha, M is equal to cos beta and N is equal to cos gamma. Please note that the sum of the squares of the direction cosines, that is L square plus M square plus N square is equal to 1. And direction cosines of a directed line are unique because direction cosines are deal with the direction angles alpha, beta and gamma. Therefore, the direction cosines of a directed line are unique. Next, we shall discuss direction ratios of a line. Number proportional to the direction cosines of a line are called direction ratios of a line. Number proportional to the direction cosines, that is L, M and N of a line are called direction ratios of a line. If A, B and C are direction ratios of a line, then L by A is equal to M by B is equal to N by C. Means L, M and N are direction cosines, A, B and C are direction ratios. If A, B and C are direction ratios of a line, then L is equal to plus or minus A divided by root of A square plus B square plus C square. M is equal to plus or minus B divided by root of A square plus B square plus C square. N is equal to plus or minus C divided by root of A square plus B square plus C square. Here A, B and C means direction ratios are given to you. If a direction ratios of a line are given to you, then by using the direction ratios, how to calculate the direction cosines? The answer is here by using this formula. L is equal to plus or minus A by root of A square plus B square plus C square. M is equal to plus or minus B by root of A square plus B square plus C square. N is equal to plus or minus C by root of A square plus B square plus C square. The direction ratios of the line segment joining P x1 y1 z1 and Q x2 y2 z2 may be taken as, here 2 points are given. 2 points coordinates are given x1 y1 z1 and x2 y2 z2. When 2 points are given to you, how to calculate the direction ratios? You must clearly understand the formulas. When 2 points are given to you, how to calculate the direction ratios? It's quite simple. Just to take the difference of their coordinates x2 minus x1, y2 minus y1, z2 minus z1, or x1 minus x2, y1 minus y2, z1 minus z2. Once again, when two coordinates are given to you, by using these two coordinates, these 2 points coordinates, p and q coordinates, how to calculate the direction ratios? The formulas are x2 minus x1, y2 minus y1, z2 minus z1, or x1 minus x2, y1 minus y2, z1 minus z2. Direction ratios of a line are not unique. Move on to exercise questions. Exercise 11.1, first question. If a line makes angles 90 degree, 135 degree, 45 degree with x, y and z axis respectively, find its direction cosines. Here angles are given, direction angles are given. We are asked to calculate the direction cosines. It's quite simple. Cosine of these angles are the direction cosines. Here the direction cosines of the line be L, M and N, the usual representation. L is equal to cos the first angle 90 degree, cos 90 degree, that is equal to 0, cos 90 value is 0. M is equal to cos 135. Here this 135, cos 135 value we have to find out. I'm going to use a logical method. You can use any method, formula also you can use, it's not a problem. The logical method is like this. First you have to divide 135 with 90. It goes one time 90. The remainder will come as 45. So this 135 we can split as cos of 90 into 1 plus 45. So this 1 represents the quadrants. This 90 into 1 in the sense it is in first quadrant, plus 45 means it moves to the second. 90 into 1 means complete first quadrant, plus sign is there, so it moves to the next quadrant, that is second quadrant. In second quadrant cos is negative. In second quadrant sine and cosec is positive, cos is negative. So this will come as negative. The answer will come as negative. And here the the number here 90 into 1, this 1 represents an odd number. If here odd number comes, you have to write instead of cos sine. If sine comes, you have to write cos. Tan, cot, cosec, sec. This is the way we have to write. Here 1 is odd number. So 1, since 1 is odd number, here it is cos. For cos you have to write sine. So minus sine here 45. That is the answer. Minus sine 45. Once again, the logical method is like this. 135 you have to divide with 90. Here 135 when you divide with 90 it goes one time. Remainder we are getting 45. So 135 we are splitting as 90 into 1 plus 45. Here 90 into 1 means it's full first quadrant, plus 45 in the sense it moves to the second quadrant. In second quadrant only sine and cosec is positive. The remaining all trigonometric ratios are negative. So the answer will come negative. And next we have to take this number. If this number is odd, instead of sine cos will come. If cos comes, sine will come. Then cosec sec cosec, then tan cot tan. That is a connection. So here cos is there. If cos comes, sine will come. So minus sine this angle, that is 45. Minus sine 45. We know that sine 45 value 1 by root 2, so minus 1 by root 2. Next is n. N is equal to cos the third angle 45. Cos 45 is 1 by root 2. So the direction cosines of the line are 0, minus 1 by root 2 and 1 by root 2. Next, move on to question number 2. Question is, find the direction cosines of a line which makes equal angles with the coordinate axis. Here we are asked to find out the direction cosines of a line. Means L, M and N we have to find out. The given condition is that line is making equal angles with the axis, x axis, y axis and z axis. Let the direction cosines of the line make an angle alpha with each of the coordinate axis. So the angle in which a particular line is making with the coordinate axis is alpha. So L is equal to cos alpha, M also cos alpha, N also cos alpha, because all the angles alpha, beta and gamma are same and we have taken as alpha. So L is equal to cos alpha, M is equal to cos alpha, N also cos alpha. We know the relation between L, M and N, that is L square plus M square plus N square is equal to 1, and L we know that cos, so L square is cos square alpha, M square is cos square alpha, again N square is also cos square alpha is equal to 1. Cos square alpha plus cos square alpha plus cos square alpha is 3, cos square alpha is equal to 1. Then cos alpha is equal to square root of 1 by root 3, that is square root of 1 is 1 divided by root 3. So cos alpha is equal to plus or minus 1 divided by root 3. Therefore, the direction cosines of the line which is equally inclined to the coordinate axis are plus or minus 1 by root 3, plus or minus 1 by root 3 and plus or minus 1 by root 3. Next, we shall discuss question number 3. If a line has direction ratios minus 18, 12 and minus 4, then what are its direction cosines? Here direction ratios are given. Direction ratios in the sense we represent it by using the letters A, B and C. We are asked to find out the direction cosines, that is L, M and N we have to calculate. Here direction ratios are given. A, B and C are given. We are asked to find out L, M and N. So we have learned the formula. If A, B, C are the direction ratios of a line, then L is equal to plus or minus A by root of A square plus B square plus C square. M is equal to plus or minus B by root of A square plus B square plus C square. N is equal to plus or minus C by root of A square plus B square plus C square. Here L is equal to A is minus 18. Minus 18 divided by root of square of sum of the squares of these three numbers, that is minus 18 square plus 12 square plus minus 4 square, that is equal to minus 18 divided by 8. Minus 18 square is 324 plus 12 square is 144 minus 4 square is 16, that is minus 18 divided by root of 484, that is equal to minus 18 divided by 22. We can cancel it, the common term, that is minus 9 divided by 11. 2 is cancelled. Next we have to go for M. M is equal to 12 divided by the second quantity, that is B divided by root of A square plus B square plus C square, that is B is 12. 12 divided by root of minus same, the previous term denominator is same, minus 18 square plus 12 square plus minus 4 the whole square, that is 12 divided by this calculation we have done and kept here, that you can take square root of 484, that is equal to 12 divided by square root of 484 is 22. When you cancel 2 common, here 6 is in the numerator and 11 will come in the denominator, so 6 divided by 11 is M. Next is N is equal to minus 4 divided by third quantity, that is C. C divided by root of A square plus B square plus C square, that is minus 4 divided by root of minus 18 the whole square plus 12 square plus minus 4 the whole square, that is equal to minus 4 divided by this quantity we calculated before, that is root of 484, just keep it, that is equal to minus 4 divided by root of 484 is 22, that is equal to 2 cancelled, minus 4 if you cancel 2, 2 will come, 22 if you cancel 2, 11 will come, so minus 2 by 11. So the direction cosines we have got minus 9 by 11, 6 by 11 and minus 2 by 11. Final answer we can write, the direction cosines are minus 9 by 11, 6 by 11 and minus 2 by 11. Next we shall discuss question number 4. Show that the points 2, 3, 4, minus 1, minus 2, 1, 5, 8, 7 are collinear. 3 points are given. We have to prove that they are collinear. Collinear in the sense lying in the same line. So let's have a rough sketch. That is, let's take the point as A 2, 3, 4, B minus 1, minus 2, 1 and C 5, 8, 7. And we have to prove that A, B and C are collinear. Means A, B and C are lying in a same line. This is a very important statement. You have to by heart and keep. The 3 points A, B, C are collinear if their direction ratios of A, B and BC are proportional. If their direction ratios are proportional, then we can say that the points are collinear. This is a very important point. Please note and keep, because when you write the formulas as you study, it will be easy for you to recollect when you go for revision. So here the first point from this chapter, that is the point A, B, C are collinear. If we want to prove the collinearity of 3 points, we have to prove that the direction ratios are proportional. Here A, B and C we have taken. We have to prove direction ratios of AB and BC are proportional. We have learned that how to find out the direction ratios of AB. When 2 points are given to you, coordinates of A and coordinates of B are given to you, means we know how to calculate the direction ratios. By using the same formula, we can calculate the direction ratios of BC as well. So let's take first AB, points A 2, 3, 4, and we have taken B -1, 2, 1. Direction ratios, it's quite simple there. Just take the difference of their coordinates, that is -1, -2, then -2, -3, 1, 4, x2 minus x1, y2 minus y1, z2 minus z1. That is equal to -1 -2 is -3, -2 -3 is -5, 1 -4 is -3. Therefore A1, let's take the direction ratios of first line, that is AB as A1, B1, C1. So A1 is -3, B1 is -5 and C1 is -3. Then we have to go for the next line, that is BC. Coordinates of B -1, -2, 1 and coordinates of C 5, 8, 7. Then let's take the direction ratios of BC. x2 minus x1, that is 5 minus -1 is written, 8 minus -2, then 7 minus 1. That is equal to 5 minus -1 is 5 plus 1, that is 6. 8 minus -2 is 8 plus 2, 10, and 7 minus 1 is 6. So here when you check the direction ratios, let's take this one as A2, B2 and C2, because we have taken before as A1, B1, C1. So it's easy. Here also we have to take A2, B2 and C2. A2 is 6, B2 is 10 and C2 is also 6. So when you compare A1 and A2, A1 is -3, A2 is 6. B1 is -5, B2 is 10. C1 is -3, C2 is 6. Means A2 by A1, when you take their ratio A2 by A1, that is, since A2 is bigger one, we are taking that one first. Reverse order also you can take, it's not a problem. 6 divided by -3, that is -2 we have got. Then B2 by B, here if you take A2, here should be B2. So B2 by B1, that is 10 divided by -5, that is -2, and C2 divided by C1, that is 6 divided by -3, that is also -2. So when you take these ratios, they are same, that is -2. So A2 by A1 equal to B2 by B1 equal to C2 by C1 is equal to -2. All their ratios are same. Therefore A, B and C are collinear. So once again I want to tell you that please keep it in mind the condition. If you want to prove ABC 3 points collinear, in the sense you have to take the points in a line and 2 line segments AB and BC. Here we have got the direction ratios of those line segments are proportional, means when you take their ratio it must be same. Direction ratios of AB and BC are proportional. Next we shall discuss question number 5, the last question of this exercise. Find the direction cosines of the sides of the triangle whose vertices are 3, 5, -4, -1, 1, 2 and -5, -5, -2. Here we are asked to find out the direction cosines, means L, M and N. For that purpose, the vertices of triangles are given, that is 3, 5, -4, -1, 1, 2 and -5, -5, -2. So let's take a rough diagram. We have taken the triangle as ABC and we have marked the points also. So let us assume A 3, 5, -4, B -1, 1, 2 and C -5, -5, -2 are the vertices. There are 3 sides AB, BC and AC. So here we have learned the formula for finding the direction cosines L, M and N. If direction ratios are there, A, B and C are the direction ratios, means L can be calculated a by root of a square plus b square plus c square. M is equal to b by root of a square plus b square plus c square. N is equal to c by root of a square plus b square plus c square. So first of all, we have to calculate A, B and C. A, B and C are the direction ratios. We already learned how to find out the direction ratios when two endpoints of a line segment is given. So here the direction ratios of the side AB. As I said before, there are three sides AB, BC and AC. First of all, I am taking the side AB, and direction ratios can be calculated by using the formula x2 minus x1, that is minus 1 minus 3, and y2 minus y1, that is 1 minus 5. Then z2 minus z1, that is 2 minus minus 4, that is minus 1 minus 3 minus 4, 1 minus 5 minus 4, then 2 minus minus 4, that is 2 plus 4 is 6. So we have got now A, B and C direction ratios we are having. Now we have to use this formula, L, M, N formulas. We have to go for calculating the direction cosines. So the direction cosines of A, B are L is equal to a by root of a square plus b square plus c square. Here a is minus 4. Minus 4 divided by root of minus 4 square plus minus 4 square plus 6 square. That is written here. Calculation. Minus 4 divided by root of minus 4 square is 16. Again minus 4 square is 16. Again 6 square is 36. That is equal to minus 4 divided by, when you add these three terms, you will get root 68. Minus 4 divided by root 68 can be split as root of 4 into 17. 4 is a perfect square. Then minus 4 divided by, from 4 2 will come out of the square root, that is 2 root 17. 2 and 4 we can cancel. Final answer will get us minus 2 by root 17. This is L. We can go for finding M. M is equal to b by root of a square plus b square plus c square. B is here minus 4. So minus 4 divided by root of a square plus b square plus c square. That is equal to this portion already calculated and kept here. Final answer 2 root 17. So directly we can substitute, no more further calculation. 2 divided by root 17. So the final answer we can write it as minus 2 by root 17. Then n is equal to c by root of a square plus b square plus c square. So c is here 6. 6 divided by root of, again same quantity denominator, minus 4 square plus minus 4 square plus 6 square. That is equal to 6 divided by 2 root 17. 6 and 2 can be cancelled. That is equal to 3 by root 17. So the direction cosines of BC and direction cosines of CA. There are remaining two sides, BC and CA. Like this, first you will calculate the direction ratios by using the formula x2 minus x1, y2 minus y1, z2 minus z1. Then by using the formula L is equal to a by root of a square plus b square plus c square. And for M also there is a formula, N also there is. So by using these formulas, you will calculate the direction cosines of BC and direction cosines of CA. This one you will do it as homework. Dear students, today we have started a new chapter, that is three-dimensional geometry, and we have completed exercise 11.1. While solving questions from three-dimensional geometry, please compare it with vector algebra as well, so that you can easily find the difference between questions from these two topics. While practicing, if you have any doubt, please note it and keep. We will discuss it during the online session. Thank you for watching.